Hello and welcome everyone to today's webinar on simplifying operations of enterprise-grade Kubernetes at scale. Thank you for joining us. My name is Tara Van Cleve and I'm a Marketing Event Manager for the Developer Initiative here at Oracle. We're excited to kick off this three-part webinar series and introduce Oracle Container Engine for Kubernetes new features. If you do not currently have an Oracle Cloud account, we've got a special promotion with extra credits so that you can try out OKE for yourself. To access the promo, please sign up using the same email address that you registered with for today's event. We'll also be recording this session, and the link to the recording will be sent to you via email in the next couple of days. If you have any questions during the webinar, we've set up a channel in our developer public Slack called OKE New Features that you can access here at the QR code or at bit.ly/odavrel_Slack. Once you're in, you'll land in the general channel, and from there you can search the webinar channel. We'll also be checking the Zoom Q&A areas and the Zoom chat. So if you have any questions there, we will be checking those, and we'll also have a live Q&A after the demos conclude. Today's webcast will be presented by Mickey Boxall, Principal Product Manager, Rishikesh Pal, Principal Product Manager, and Jeevan Joseph, Senior Principal Product Manager. So without further ado, I'll hand it over to Mickey.
Hey folks, let's run through a quick agenda. So to begin with, I just want to talk briefly about Kubernetes momentum. Why is it that we're making these big investments in our managed Kubernetes platform? I'll talk about how that applies to OCI. At a very high level, I'll also discuss Oracle Container Engine for Kubernetes. Then I'll dive into our new features, the things that we are excited to announce that we recently released. After that, we'll segue into a demo of some of those new features, followed by a quick FAQ section that addresses some common questions from current and prospective users. And then finally, we will wrap up everything with a Q&A. Also, throughout the presentation, you may see a few poll questions come up. Please feel free to respond to those because we love getting your feedback. But also, during the presentation, feel free to ask questions using the Q&A functionality, and Rishikesh and Jeevan will both be able to answer those questions as we go. Cool. So without further ado, Kubernetes momentum. So I'm not going to go into necessarily what is Kubernetes. Hopefully the folks on this call know that already. Suffice to say that it has become really a de facto standard for cloud native developments. I remember a few years back, there was this fight between Docker Swarm and Mesos and Kubernetes and a bunch of other container orchestrators, and Kubernetes really just won outright. For those who don't know, it is an open source system for automating the deployment, scaling, and management of containerized apps. It really has become the single most popular technology in the stack. It shifted from being, I'm not going to say niche, but something that was more of a desirable goal for a lot of people to adopt, to now something that really is mainstream. I'll share a couple of stats in the next couple of slides. And also its use cases have expanded beyond stateless applications to stateful ones, ETLs, batch job pipelines. There are a lot of HPC or GPU related use cases. And of course, very stateful services like databases, all running in Kubernetes. Talking about its popularity for a moment, it's the second fastest growing open source software in history after Linux. It really is ubiquitous. Over 40% of enterprises have been using it in production since 2021. The expectation is that'll grow to 75% in 2024 and over 90% in 2026. So it's safe to say that it already is mainstream and will become even more so in the next couple of years. And other things related to popularity, the adoption of this platform continues to grow at an incredible rate. It's more than doubled in the last 5 years, and it's clear that this is something that is really a major focus for most organizations. I mean, we're seeing a massive increase, not just in the adoption of Kubernetes, but in the number of developers, cloud native developers worldwide. So segueing away from Kubernetes generally, I want to talk about why folks will use OCI and why people use OCI for cloud native development. For more detail, we'll talk about some of the benefits. It's very flexible. OCI has comprehensive compute options. you're able to specify the number of OCPUs and the amount of RAM for a given instance shape. You can also choose between different runtimes. There's container runtimes like container instances in Kubernetes. There's also bare metal, there's virtual machine runtimes. There's just basically runtimes to fit whatever project you might have. And also in terms of flexibility, you can deploy Kubernetes on top of OCI using OKE. You can use other tools like KubeSpray or whatever you want to do to manually do it, or you can use the cluster API for OCI or for OKE directly. It's very simple. A lot of the functionality has already been included out of the box in our managed Kubernetes platform, so that's not something you have to deploy yourself. We'll talk more about the new features that we've introduced that's made this even more accurate today. And I think really one of the biggest differentiators for OCI is price performance. Not only can you use the flexibility of the platform to do things like right sizing your workloads by specifying the right size for your compute shapes or load balancer shapes, just fundamentally, it has a better price performance than our competitors. I would say a lot of the times when we hear folks moving from AWS to OCI or Azure to OCI or Google to OCI, the main driver ends up being cost. Because if you look at like workloads, and do an apples to apples comparison of your deployment, it's going to be substantially cheaper when running on OCI. And we'll also talk a little bit more later on in the presentation and more in this webinar series regarding how some of the new functionality that we're introducing actually makes this cost optimization even more compelling. Things related to cost optimization tied to virtual nodes, or just the total cost of ownership reductions that come from using enhanced clusters. So as I mentioned before, we have a very flexible runtime strategy. We have options that are bare metal compute. So if you want to have full control over the actual bare metal infrastructure that your systems are running on, that is something that's available to you. All the way on the other end of the spectrum, we have pre-built functions, functions that are already available out of the box to perform common use cases. And, thankfully, we have everything in between as well. On the Kubernetes side, this sort of stretches from being able to deploy Kubernetes from scratch yourself on top of bare metal infrastructure or on top of virtual machines, then going one level up, being able to do so using the Kubernetes cluster API. This is beneficial for folks that are doing things like using Tanzu or other systems that leverage the cluster API to deploy their platform. Going one level above that, we also have managed Kubernetes, which is OKE. It's the product that I manage, which is our managed container orchestration platform. And this really is just sort of the quick to deploy, managed control plane version of Kubernetes that you see offered from providers, other providers in the ecosystem. Within that, you can either have managed nodes or virtual nodes. We'll talk more about virtual nodes in a few minutes. But basically, this is just different levels of control over the data plane of your cluster, whereas the control plane will always be fully managed. And if you wanted to take one step further and not deal with Kubernetes API at all, but instead just deploy containers directly, you can use OCI container instances. So the goal of this is really just to demonstrate that OCI has solutions regardless of what stage you are at in your cloud native journey, and regardless of what your use case looks like. Now, before diving into the actual features, just some other benefits of using Kubernetes on OCI. What we're really striving for is doing three main things. It's lowering the total cost of ownership, which means reducing the time and cost and effort needed for operating Kubernetes at scale. It's also accelerating the adoption of Kubernetes in your company. It's trying to remove some of the steep learning curve that's associated with adopting a containerized platform or a cloud native development approach. And also in doing so, it's about improving developer productivity and time to market. Now, how are we doing so? We're doing so by reducing the operational burden because we're taking more of that onto ourselves. In the case of virtual nodes, we're actually managing the worker node hosts in your system, so you don't have to do that any longer. In the case of add-ons, we're taking over management of Kubernetes operational software. So this reduced operational burden takes place at sort of multiple levels of the Kubernetes stack. And in doing so, we're reducing the amount of risk related to operations, and also trying to optimize those operations. Also, as a result, we're trying to increase your agility and flexibility. We're increasing your agility without sacrificing flexibility. So as I mentioned before, there's not just, one shape family available to you. It's not just x86 hardware. You can use ARM shapes, you can use GPU shapes, you can use flexibly sized shapes or the more traditional ones. All these are available depending on what your use case looks like. And all of it comes with the benefit of lower cloud costs in total, regardless of whether your workload is Kubernetes based or otherwise. And then just state those points one more time. We are introducing a bunch of out-of-the-box capabilities based on best practices that end up helping you lower your total cost of ownership. We'll talk about what's available today, and we'll also talk about some things that are on our roadmap that can help these in the future. As I mentioned, we're trying to help our users accelerate Kubernetes adoption and simultaneously increase developer productivity. And of course, in doing so, we also want to make sure that cost optimization is something that's an area of focus as well. And just the final rehashing of this, these are some of the key values that we see of using Kubernetes on OCI. Now, switching gears a little bit, just because I wanted to hammer home one more time the benefits of Kubernetes on OCI, I felt like it would be better to not just have me talk about it in a vacuum, but actually share some of the quotes that we've gotten from some of our customers. So in the case of SoundHound, they have run their AI query application on top of OCI, on top of OKE, and really been able to benefit from the flexibility of the platform. So as I mentioned, it doesn't just support, Intel hardware. You can also use GPUs and high performance computing use cases and other modern developer services that make it a lot easier to really see major benefits from the platform. So in the case of SoundHound, they use OCI to train their AI applications. Now, in the case of Wiz, they've really been able to leverage OCI and OKE, our managed Kubernetes platform, to really facilitate the rapid growth of their company. Rather than focusing on spending resources on infrastructure management, they've been able to take advantage of the fact that a lot of these things are available from OCI, from OKE out of the box, and they don't have to end up wasting developer hours, doing those things themselves. And finally, another big customer of ours, GoTo, has been able to standardize on Kubernetes, not just at OCI, but also with other providers, and benefit from the fact that they can have consistent operations across providers. And in their case, they've actually been able to make major cost savings by moving workloads to OCI. All right, now the part that I expect a lot more folks are excited about, which is actually talking about the new capabilities themselves. So all of these things have been recently released, and a few at the end are ones that are in our near-term roadmap. So to begin with, I wanted to talk about virtual nodes. So within the Kubernetes space, it's typical to see your control plane be fully managed by your provider. So the control plane, when I say that, what I'm talking about is at CD, it's the Kubernetes API server, the cloud controller manager, the kube controller manager, and the kube scheduler. So all of those things are essential for basically controlling all the resources and deploying all resources to your Kubernetes environment. Now, the challenge typically relates to operating the data plane, which is where those workloads are actually scheduled. The reason the data plane can be really challenging is just because data plane has kind of a shared responsibility model. It's typically deployed by your provider, but it's actually managed by you. You're responsible for upgrading it, for scaling it, for troubleshooting it, ensuring those hosts remain healthy and online. And also, of course, there are things that you can do during the process of owning that that can actually negatively impact the health of nodes, or make things harder for your workloads to schedule properly. Maybe you have an improperly configured pod disruption budget. Maybe you've done something odd with taints or tolerations or node topology constraints. There are anyway, just a lot of challenges that come with managing the data plane. So traditionally within our Kubernetes offering, we've had what are called managed nodes. Managed nodes are simply Kubernetes worker nodes backed by OCI compute shapes. Those compute shapes can be bare metal, they can be virtual machines, they can be GPUs, they can be ARM, they can be Intel. And with those shapes, you had the ability to SSH into them, run whatever you want on them, use custom cloud init configurations to actually bring your own software. You can use your custom image. You really have a lot of ownership and flexibility when it comes to those worker node hosts. But for a lot of folks, that flexibility was not worth the responsibility that came with it. So people came to us and said, we don't want to manage data plane upgrades. We don't want to have to upgrade the host every time a new OS version comes out. We don't want to have to upgrade the host every time a new Kubernetes version comes out. We really just don't want to worry about this. Similarly, we don't want to own cluster autoscaler. We don't want to own the actual automatic scaling of the node level of your cluster. Instead, we want to offload that to someone else, to someone who knows how to optimize it and who knows how to control it properly. And of course, we also don't want to manage node health. We don't want to have to run some sort of node auto repair feature to ensure that nodes are always running and always healthy. We want to offload that to a provider that knows what they're doing. And so as a result, what OKE did was introduce something called virtual nodes. And virtual nodes, as you can see in the diagram on the left, they offload the majority of that responsibility from Oracle, or excuse me, from our users onto Oracle. So virtual nodes remove the need for our users to manage worker node infrastructure. You only need to manage your applications via the Kubernetes API. Now, simplifying those operations and optimizing resource utilization go a very long way to lowering the total cost of ownership. When I talk about resource utilization benefits, it's because we're shifting from a model where you deploy full compute instances and leverage only part of those instances because you're not going to be using every single piece of memory or cores on a box. You're only using a portion of that. And now instead, you're actually shifting from that to paying for the resources used by Kubernetes pods. And those pods they're charged at the container instance level, or the same container instance price. So what you would do is you'd set the resource reservations for your pods. You're specifying the amount of OCPU, the amount of memory that each pod requires, and that's all you're paying for. So there's not going to be any wasted space left on the box. Now, you're also getting the benefit of the simplified operations that I talked about. So you have to patch the host OS any longer. You don't have to scale the infrastructure. That's done automatically for you. And you also don't have to troubleshoot the infrastructure. And upgrades are performed seamlessly on your behalf. So again, the idea there is reducing the burden that's placed on our users and taking more of the ownership of ensuring the health of worker nodes or of the data plane onto Oracle. When it comes to scaling, of course, you're going to be focused on scaling at the Kubernetes API level. What that means is that you'll probably implement things like horizontal pod autoscaler to, create new replicas of pods running in your system. But again, you don't have to focus at that node level of autoscaling. Instead, all of that is managed for you. You also have the benefit of enhanced security. So what's cool about this model is that each virtual node runs not on a shared host, but instead in its own host, which means you have pod level workload isolation. You also, because of how this is hooked directly into our virtual cloud networks, benefit from additional network security, such as control over routing, the use of network security groups, and being able to introspect the communication between pods using BCN flow logs. And all those things go a long way to enable multi-tenant use cases. So just to rehash, you have the benefit of simplified Kubernetes operations. You have the ability to right-size your workloads, and also you have the ability to benefit from enhanced security as well. So another one of the core features that we just released is referred to as Add-on Lifecycle Management, or the Add-on API. So within a Kubernetes cluster, even if you provision a brand new cluster, you'll typically see that a provider has provisioned certain essential tools or add-ons into that cluster, even if you've deployed nothing yourself. So for example, if you were to create a new cluster and run kubectl get pods in the kube system namespace, you'll see that things like kube proxy, core DNS, and your CNI, your cloud native, or excuse me, your container networking interface, for example, native pod networking, or Flannel, those pods will already all be deployed to the Kubernetes kube system namespace. What we've done with this feature is two things. One, we've allowed customers to deploy additional add-ons to that same namespace, in the same fully managed manner that it previously was. So for example, now users can select to deploy the Oracle database operator if they want to deploy Oracle databases either into their cluster or connect to ones that are deployed outside of the cluster. Also the Kubernetes dashboard, if they want to manage Kubernetes resources or visualize those resources, they can deploy the dashboard with one click as if it were an existing type of cluster add-on. The benefit there is that all of the management of those add-ons, which includes, maybe building the image from scratch, updating it over time, creating replicas, all of those things are offloaded from you onto Oracle. So that's not anything you have to worry about anymore. Now, on the flip side, because I did say there were two things that this feature allows you to do, it also allows you to do almost the exact opposite. And what I mean by that is previously, if you made an update to something like core DNS, maybe you updated the core file because you wanted to change the way that your DNS was configured in your cluster. OKU would actually reconcile those changes and would override them. And the reason for that was basically just to ensure cluster health. And it was to make sure that everything was running properly. And we just didn't give our users the mechanism to opt out of those automatic changes. And now with this new API that we've introduced, you actually can opt out of those automatic changes. If you wanted to, you could remove our CNI entirely and bring your own. So if you didn't want to use native pod networking, if you didn't want to use Flannel, if you wanted to use something like Calico or Cilium as your CNI, you could actually just opt out of using our CNI altogether. And as long as you know what you're doing, we're giving users the ability to bring their own CNI. And that applies to more than just CNIs. There's also, other sort of fundamental or essential add-ons that users can now opt out of or opt out of the automatic updates of and bring their own technology to replace it. So again, I know it's a little bit confusing to understand, but there are two very different things this feature introduces. You can either opt into Oracle provided add-ons and opt out of needing to manage this technology yourself, or you can do the opposite and opt out of those Oracle provided add-ons to bring your own software. So this is a very cool, very powerful feature that will make it easier for early users to get started with adopting cloud native practices, and also provide flexibility to more advanced or mature users who know what they're doing. Now, the next big feature is Kubernetes workload identity. And what's great about this is it gives users the ability to improve their security posture by providing more granular access control to clusters. Previously, users were stuck limiting control over OCI IAM to the node level, which meant that basically every single pod running on that node would be granted the same level of access to OCI identity and access management policies. And now we've gone one step deeper, really to the deepest step that you can possibly go to, which is actually authorizing specific Kubernetes pods to make OCI API calls and access OCI resources. So for example, as you can see in the diagram on the left, if you wanted to authorize a Kubernetes pod to read objects in an OCI object storage bucket, now you have the ability to do that at the pod level. You create an IAM resource principal, attach it to a service account associated with that pod, and then that would grant just that pod, not any other pods, but just the one that you set, the ability to interact with that OCI resource. What's cool about this is it allows you to apply the principle of least privilege to your apps. And also because it's hooked into the Oracle Identity and Access Management service, you can track all the API calls from those Kubernetes pods using the OCI audit logging service. So what I think is cool about this is that it can do more to help enable multi-tenant workloads, again, by adding that extra level of granularity, and really just facilitates the process for applications that need to access OCI IAM policies to connect to other OCI services. Something else that's actually coming out today is preemptible worker node support. So preemptible worker nodes are basically just preemptible compute instances, which come with a lower cost in exchange for the possibility that they are preempted, which means that if someone else requests the same capacity, you'll get a quick warning, and then the instance may be reclaimed. Now, the benefit here is that it is a pretty drastic cost savings. So when you use a preemptible VM, which is equivalent to an AWS spot instance, you'll actually benefit immediately from a 50% discount on the on-demand instance price. And that's a discount that exists regardless of shape or region where a compute instance is deployed. So if you have a workload that's interruptible, if you have a very stateless application that is fault tolerant, you can take advantage of these instances that come with their lower availability guarantee. What we've done is previously, you could just use these as compute instances, and now you can use these as worker nodes in your cluster. And what's great about this is that, a lot of cloud native applications are designed with interruptibility in mind. And so this is a great way for our users to, again, optimize the costs of their workloads. It's also worth calling out that a cluster can have a mix of on-demand and preemptible worker node instances, so they're not stuck with just one capacity type. And because this is hooked into Kubernetes, you can use the Kubernetes API to control the type of node that a pod is scheduled on. So if you have particular pods that are more fault tolerant, you could, sort of write your application in such a way that only pods that are fault tolerant are scheduled onto preemptible worker nodes, or vice versa. Now, a couple more features that are coming out in the next few months that I wanted to talk about before shifting into the demo are on-demand node pool upgrades and self-managed nodes. So as I mentioned before, one of the pieces of feedback that we got from our users was that it's very challenging to do things like control the node upgrade process. You have to today actually orchestrate the way that nodes are upgraded over time. And when I say upgraded, I don't necessarily just mean Kubernetes version, but basically just the application of any change you might make to a node to all the other nodes in the node pool. And so what we've done with this feature is just made it easier for customers to apply the changes that they've made to a node pool to the other nodes in the pool. And so why would that be an issue? Well, the way that it works today is, unfortunately, when you make a node pool change, it doesn't actually propagate to the existing nodes in the pool. It only is available to new nodes creating in the pool. And the problem here is that you're responsible for figuring out how to rotate or cycle the nodes in the pool. So what that means typically is a customer will have to go in and using Kubernetes tools like cordoning and draining workloads, they'll have to sequentially delete all the existing nodes and create new nodes in such a manner that limits downtime to their application. What we've done with this feature is simplify the worker node upgrade process. What you can do is just as today, you change the parameter of your node pools. You can change the Kubernetes version, the image, the shape of the worker nodes, or other parameters like the cloud init script that runs or your SSH key. And you can simply just click apply, and that will apply the changes on demand. This feature leverages typical Kubernetes deployment best practices like max surge and max unavailable, which can either prevent downtime or reduce costs respectively. Max surge basically allows you to increase the number of nodes that you add to your pool to shift workloads onto, whereas max unavailable limits the number of nodes that can be down concurrently. These upgrades are performed at the node pool level. So you can upgrade one node pool at a time or multiple if you so choose. And node pools are terminated and replaced in a manner that respects the eviction grace periods that you've set for your nodes, and also things like pod disruption budgets as well. And the final feature I wanted to share today, and something else that's coming out shortly, are self-managed nodes. So what's cool about this is that within an OKE cluster, as I mentioned, you have access to nodes, worker nodes, which are backed by compute instances of different types. Now, the one thing I will say is that not every single compute instance type is supported today. There are certain limitations that prevent us from supporting all compute instance types. And there's actually other constructs like instance pools that we don't support because it's a little bit awkward to have multiple orchestration tools contributing to the size of something like an instance pool at the same time. What's cool about this feature is that for the first time, we are allowing our users to add any OCI compute instance or instance pool to an existing OKE cluster as what we're calling self-managed nodes. So basically, you can bring any of those compute instances to your cluster as a worker node in the cluster. So this removes that limitation of shapes and images that we previously had. And it also comes with the benefit that Kubernetes labels are automatically added depending on the type of instance that you're adding, which allows you to benefit from the capabilities of pod scheduling that we talked about before with preemptible instances. Also, things like node metrics and logs are automatically emitted to the monitoring and logging service. And the workloads that we see really benefiting from this are, first and foremost, I would say, high performance computing workloads. And, so for example, if you had a cluster network of GPU nodes for your machine learning workload, you could bring that cluster network to your Kubernetes cluster and then use the Kubernetes API to schedule work onto it. Which is great because sometimes those cluster networks don't have a great orchestrator that they're being controlled with. So this basically allows you to leverage your knowledge of the Kubernetes API for those more advanced use cases. Cool. So now switching gears, I'm going to move to a quick demo of things. And then after the demo, we'll dive into a Q&A. So right now I am on the OKE console. I guess the OCI console, but I'm in the OKE section of the console. And I'm just going to go through the cluster creation process and then click into an existing cluster. So as I mentioned before, OKE makes it fairly straightforward for users who are just getting started with Kubernetes. You have an option to choose a quick create cluster, which will actually create not only the Kubernetes control plane and data plane, but also all of the required networking resources as well. I would definitely recommend this approach if it's your first time creating a cluster, because things like virtual cloud network configuration can be pretty cumbersome and involve a lot of steps, each of which can end up being a pitfall for you, because I think sometimes network configuration is where our users will get tripped up. Alternatively, if you know what you're doing, or if you already have VCNs created that you want to leverage, you can instead use the custom create option, which gives you the ability to have more control over what's created in your cluster. So I'll begin by just naming my cluster, call it test. I can choose the compartment that I want it deployed to, and also the Kubernetes version of my cluster. Now, OKE supports the same Kubernetes versions that the upstream project supports, and it trails the upstream project by about 90 days. So currently we support 125, 124, and 123, and we'll be adding support for 1.26 within the month. Now, because this is a custom create, I have access to some advanced options. I could enable image verification, which is the ability to add an additional level of security to my cluster related to ensuring that only signed or approved images are deployed on the cluster. I can encrypt secrets using an Oracle managed key, which is the default option, or my own customer managed encryption key. And if I go a little bit lower, I can show you cluster add-ons. So this is one of the new features. So over time, you'll start seeing more features added to this section. In fact, in the next couple of weeks, you'll start seeing the Oracle Database Operator and Certificate Manager here as well. As I mentioned, there are certain add-ons that are deployed by default. So Core DNS and Kubeproxy. You can, if you prefer, remove those, but that is done at your own risk. Kubernetes dashboard is an example of an optional add-on. It is disabled by default. If I want to enable it, it's easy as just clicking in the enable add-on button. I can choose to have it automatically updated. I could also choose to pick a version. And the other thing that's cool about this is that there are certain customizations that are available and supported out of the box. So for example, if I wanted to choose the number of replicas of the dashboard, I could set a value for that as well. If I wanted to instead use node selectors or tolerations to control onto which nodes the dashboard is scheduled, I can use that as well. And what's nice about this is that these are customizations that will not get overridden by OKE. Depending on which add-on you're talking about, they'll have specific, add-on specific customizations. For example, with Core DNS, I could actually bring my own config map that updates the core file if I so chose, and those customizations would not be overridden, even if I did have OKE automatically update my add-on. So I'll save changes there, which means that the dashboard will be deployed to my cluster. Then I'll click next. I have the choice between multiple CNI types. I can use VCN native pod networking, which is a network that hooks directly into the OCI VCN. Or I can instead choose a flannel overlay network instead. So choosing the VCN native pod networking default, I will select one of the VCNs I've already created. I'll also select a subnet for my load balancers and also the subnet for my Kubernetes API endpoint. All these are things that I previously configured. And then next up, I'll choose my node pool. So in this case, I am going to create a virtual node pool. I can call it virtual node test, and I will choose the 1.25 version. So as I mentioned before, managed nodes are simply worker nodes backed by compute instances, whereas virtual nodes are worker nodes backed by container instances. These are the ones that are charged based on my pod resource reservations. These are also the ones that you get the most benefit from when it comes to cost optimization, because again, all of them are right-sized. They're based just on the resources that you request. And the whole data plane layer is, again, scaled dynamically. The last step is choosing the count of my nodes and also the shape for my nodes. So in this case, I'll have 3 virtual nodes. You may be wondering why it is that you want to have a number of nodes, given that these are virtual. The answer is that each node has certain configuration options associated with it. You can choose a different pod shape. There will be more available over time, but you can also choose your own constraints to do things like distribute the nodes. So for example, each virtual node could be in its own subnet. It could be in its own availability domain and fault domain. And based on what you select for your nodes, resources will be scheduled in different ways. So in this case, I'm choosing different fault domains and different availability domains for my virtual nodes, which will ensure that workloads get scheduled accordingly and with sort of maximum distribution in mind. Final step is to just configure or confirm all of the configurations I just made. I can again see the add-ons that I've scheduled here. And then I'll just click create cluster. Cool. So I know that it looked like it was very fast. The cluster itself is still being created, but all of the resource creation requests have all been accepted. So now I'll jump into an already configured cluster. And then this will be the last step before I go into some of the FAQ and then go to a Q&A. So this is one of my existing clusters. You can see here that if there were a new Kubernetes version available, I could click that here and that would upgrade my control plane. In the case of virtual nodes, it would also do a data plane upgrade as well. I have the ability to access my cluster either via Cloud Shell or local access, depending on the VCN that I've configured. And just to focus on the new features, if I were to go to my add-ons, I could come down here and click Manage Add-ons to see the add-ons running in my cluster. So in the case of this cluster, I didn't configure the Kubernetes dashboard out of the box. If I wanted to do so after cluster creation time, I could click the add-on, click Enable Dashboard, and then save changes to basically see the Kubernetes dashboard deployed to my cluster. Alternatively, as I mentioned before, after you create your cluster, you can do things like remove essential add-ons entirely. Now, we don't recommend doing this if you don't know what you're doing, but if you do, and if you want to bring your own CNI, this is exactly how you would do so. You click Save Changes, and then all new nodes that come online would come online lacking the pod that configures native pod networking. Cool. So in this case, yeah, it looks like I have my virtual node pool. I can see the taints on the node pool. I can also see tags on the node pool. And if I wanted to, I could add tags as well. One thing that's a big difference between virtual nodes and provision nodes or managed nodes is that because these are virtual and you don't have host level access, you wouldn't be able to SSH into them if that's something that you previously were expecting. So that about wraps up what I wanted to demo. So I want to share this because there are a lot of different types of customers running on OCI and running on OKE. So on one hand, we have American Airlines, which moved their AA Advantage loyalty system onto OCI. And that was just a very brownfield activity. That was a legacy Siebel implementation that they were able to transform into a cloud native application. It's very cool because in this case, it's not some sort of net new, fully stateless cloud native application. In fact, it's a very kind of old school legacy, gigantic enterprise application that they were able to decompose in certain ways and turn into a cloud native application. Alternatively, Red Bull Racing was able to replace their HPC solution with the flexibility offered by OKE on top of OCI's infrastructure. They were able to scale their cluster to thousands of Ampere A1 cores during races to run their Monte Carlo simulations that help with decision making. And nice thing here is that the elasticity of the platform is really what helped them save on costs related to HPC, which of course are typically pretty costly workloads. But suffice to say, there's a lot of different use cases that are all applicable to OKE's platform. So one other thing I wanted to address is that a lot of these new features are part of what we're referring to as enhanced clusters. Basic clusters are how we refer to our existing type of OKE cluster, which is basically just like the most fundamental version of the service. It has a completely free control plane, but lacks some of the new functionality that we have just addressed. So just to talk about that for a moment, we had some sort of frequently asked questions related to this upgrade process. Why upgrade? If I have a basic cluster and I'm comfortable not paying for a control plane, why is it that I would want to pay, an additional 10 cents per hour for my control plane? Well, the answer to that is that the features that we're adding, like virtual nodes, like workload identity, like add-ons, can end up lowering the total cost of ownership by reducing the amount of operation and management requirements and overhead on our customers. Also, benefits related to cost optimization tied to virtual nodes are another reason for that. With that being said, it's not a requirements upgrade. You don't have to use these new features. You don't have to upgrade your cluster. All the functionality offered by the new features is feasible with the existing OKE clusters. The new features really just try to simplify the process of getting people to use them. When it comes to things like node management, you can today upgrade all of your nodes. The new features make it a little bit simpler to do so. If you don't upgrade, again, there's no consequences. You just won't be able to benefit from the new features. And do you need to make application changes to upgrade? The answer to that is no. The new features, the enhanced clusters simply enable the use of new features, which are additional APIs. No current functionality is deprecated. We're not leaving basic clusters in the dust or anything. All the fundamental infrastructure and security updates will be available to both cluster types. Really, this is just about adding more simplicity and reducing the amount of management overhead for our customers' clusters. Also worth calling out that the cost compared to owning and operating a cluster is pretty negligible. It's 10 cents per cluster per hour. That's the same price you'll see from AWS, from GKE, from Azure. And again, some of those new features will go further to lower total cost of ownership, making this actually a net reduction in cost. Also, as I mentioned before, one of the OCI's major value props is price performance. And not only is that control plane cost consistent with other providers, but just the fact that OKE runs on OCI infrastructure means that your workloads will typically be 30 to 40% less than you'll see on other providers. And then when it comes to the data plane costs, there is a cost to running virtual nodes. There's a small management fee per node. And of course, the cost for the underlying container instance resources. But again, it's 0.015 cents per node per hour. So this is nothing else that will break the bank. Cool. So now I am happy to open the floor to questions. Thank you, everyone.